Okay, so here we are going to discuss regarding types of uniaxial interference figure. One is optic axis figure, off-centered optic axis figure, and then optic normal figure. So you can see the microscope is having its crosshair that is showing the vibration of polarizer and analyzer, right? So when the optic axis is at the center of crosshair, that means the section is like this. Here it is the optic axis. That means in 3 dimension you can show like this. This is the optic axis. This is the optic axis. Now optic axis is at the center of the section or center of the crosshair, right? So that is your optic axis figure. What is off-centered? The optic axis is somewhat like here. That means if we are taking a section here, here, what happens? You are viewing that the optic axis is like this. If we are taking that section, the optic axis is like this. If you are taking this section, right? You are taking this section. Okay, this is the mineral. This is tetragonal system. This is my optic axis. If I am taking this section, if I will put that on stage, I am taking this section, I am put that on stage. So the optic axis is like this. So that is not at the center of crosshair. So that will be off-centered optic axis figure. When talking about optic normal figure, you are taking this section. That means the principal section. In principal section, what happens? The optic axis is like this. So if we are putting that on microscope, that will be like this, right? Optic axis is parallel to stage, light rays are perpendicular to the stage. Then that will be your optic normal figure or flash figure. So there are two concepts that is not in a part in this type of uniaxial, but let me confirm what is optic normal and what is wave normal. Anyone is having the answer? Optic normal and wave normal. Talking about optic normal, that is the perpendicular to optic plane, or perpendicular to optic axis. Obviously optic plane will contain the optic axis, so that is perpendicular to optical plane. That is your optic normal. What is wave normal? Perpendicular to vibration direction. This is my light ray. Now the particles are vibrating like this. So you can say this is your wave normal. And now the wave normal is coinciding with the path direction. Now the wave normal that is coinciding with the path direction. If this is the path direction and the ray is vibrating like this. Extraordinary ray, this is for extraordinary ray. For ordinary ray, that will vibrate perpendicular to the path direction. For extraordinary ray, that is not vibrating perpendicular to the path direction, right? So for extraordinary ray, if we are considering the wave normal, that is somewhat different from the path of, or direction of propagation. This is propagation direction and this is wave normal. Vibration directions are this. Okay? For O ray, the wave normal is equal to direction of propagation. Got that? So this is one more difference between ordinary and extraordinary ray. So now going to different types of figure. I have already discussed how you can obtain optic axis figure. You can see this is the optic axis figure. The center part or the melatope, that is representing the position of optic axis. These are outward rings. When the angle will be greater, retardation will be greater. Those are forming greater higher order of interference color outward, right? So these are isochrones. So I have already drawn this diagram. This is for indicatrix of a uniaxial mineral. You can see the vibrations are which are in basal section, those are will be vibration of 4A, which are in principal section, those are of epsilon, and these are the light rays. These are the light rays. You can see here it is mentioned E dash, epsilon dash. You can see here it is mentioned epsilon dash. So why epsilon dash? I have told you yesterday, that is for random section. When it will be maximum, then we are taking it epsilon. Okay. So the figure will be like this, where there is matching of vibration, those will extinct, forming isogear. In other, there will be production of interference pattern, so that will be isochrones. Okay. Now off-centered optic axis figure. Okay, one more thing. If we will rotate the stage in optic axis figure, if we are rotating the stage, then what will happen? If we are rotating the stage, what will happen? If we are rotating the stage, you can see this vibration shift to this position and this vibration shift to this position. So this vibration will mismatch here. Let's say A point is here, B point is here. If I will rotate that, B comes to A position, A will be here, B will be here. Okay. So this vibration direction that will match now with the polarizer and analyzer, but A will mismatch. Got that? A vibration direction at A point, those vibrations are there, that will mismatch with the polarizer and analyzer, but B will match with polarizer and analyzer at this position. So you can see the isogear is not shifting here, the isogear is fixed. If we are rotating the stage, the isogear is fixed, but the stage is rotating. The isogear doesn't change the position in case of uniaxial mineral. In the case of uniaxial mineral, when it is optic axis figure. When it is optic axis figure, there is no change of position of isogear. There is no change of position of isogear. Then talking about off-centered optic axis figure, you can see the indicatrix is like, if this is the section, the indicatrix is like this. Got that? That means this is the optic axis. This is the optic axis, which is not at the center of crosshair, that is at an angle. So you can see the melatope somewhat here in the quadrants, not at the center, you can see it here. And if we are rotating the stage, then what will happen? The melatope along with isogears, that will rotate. The melatope will rotate accordingly, because the optic axis is going to rotate, right? Then what is the position of optic axis? If someone asked you what is the position of optic axis, there are options like this. In JAM there is a section which is having double answer, right? Multiple answer question. So let's say I am asking in interference figure, which of the following, or bracket में is, that means that there may be one or two answers, right? Which of the following is showing the position of optic axis, is representing the position of optic axis, right? In uniaxial interference figure, the position of optic axis is shown by dash, right? So first one is melatope, second one is center of crosshair, third one is center of isogear or cross. Isogear is center of isogear or cross of isogear, anything. Intersection you can write, intersection of okay. Let's say these three options are there, and fourth one is all of the above. So which one will be the answer? I am talking about uniaxial interference figure, position of the optic axis. But all of the above. 1 and 3. Melatope First one is melatope, second one is center of crosshair, third one is intersection of isogyre, fourth one is all of the above. So which one will be the answer? The answer will be 1 and 3. Why? It is not mentioned here, it is optic axis figure. Not mentioned here, it is optic axis figure. So it can be off-centered. It can be off-centered. If there is melatope will denote you the position of optic axis, no doubt. Intersection of isogyre, that can also show the position of optic axis if it is mentioned here uniaxial. If there is uniaxial. If there is only interference figure, okay, what is the position of optic axis in interference figure? Position of optic axis in interference figure. There is no uniaxial and biaxial. Then what are the answer? Answer will be only melatope. Answer will be only melatope, because in biaxial it doesn't, the isogyre intersection, that doesn't signify the position, that doesn't represent the position of optic axis. Got that? There may be this question like this. If it is talking about uniaxial, then that can be melatope and intersection of isogyre. If that is a MCQ question, only one choice is there, so you have to answer only melatope. You have to answer only melatope. Even the question is same, but you have to answer melatope, because the intersection of isogyre, that doesn't show the position of optic axis in biaxial minerals. Here it is a coincidence that the intersection of isogyres that falls in the melatope region for uniaxial mineral. Got that? So the question can be asked like this. Now, talking about optic, you can see this is for off-centered optic axis figure. Off-centered means you can see the optic axis that is not at the center. Okay, you can see that is out of the field of view. This is our field of view, and the melatope is forming out of the field of view. Then how to know where is the position of melatope? If there is, you can see these diagrams. Here it is, in the field of view there is no melatope. In the field of view there is no melatope. So how to define which is the position of melatope? Just see the thickness of isogyre. Just see the thickness of isogyre. In the direction of decreasing thickness, there is the melatope. Right? Now talking for optic normal figure, you can see the optic axis is perpendicular to the light rays or parallel to the stage. Optic axis is parallel to the stage or perpendicular to the light rays. So what happens when you are taking a section which is parallel to optic axis, you can see the indicatrix. The circles are increasing in radius. If you are going away from optic axis towards the center. You can see this indicatrix figure. If you are moving away from this one, this optic axis, the circles are increasing in radius. So if there is increase in radius, there is decrease in curvature. That means the lines are more straight. Got that? So what happens? Everywhere you can see there is matching of vibration. Because the angle change in very less amount at very greater distance. You can see from here these positions are only showing interference. These positions, very few positions where the vibration is mismatching with the vibration of upper polarizer and lower polarizer. That position is very less. Okay, in all of the positions you can see due to the greater diameter, greater radius of the circle, the curvature decreases, so there will be straight lines, almost straight lines. So the vibrations will match with the polarizer and analyzer at a position. So what happens? The entire interference figure or entire figure will extinct, except some of the interference color, except some of the portions showing interference color. All of the portions they are going to extinct, so there is darkness. If you slightly change the position, slightly rotate the stage, you can see the stage is rotated here, like this. So what happens? If you slightly rotate the stage, the all of the vibrations they are going to mismatch with the vibration direction of polarizers. But that if we are slightly rotating the stage, the vibration directions of mineral, those are in all positions, those are going to mismatch with the vibration direction of polarizer and analyzer. You can see this light rays, this light color, or sorry, these rays, these are showing vibration of polarizer and analyzer. Okay, these one, and all others they are showing vibration direction of the mineral. Okay, you can see there is mismatching of vibration in all above except these two positions. So this darkness that is going to disappear with slight rotation of stage. This darkness or this extinction that is going to disappear with slight rotation of stage because of mismatching of vibration in entire section. Got that? So this is known as flash figure. That's why it is known as flash figure. It is obtained for a certain for a very less time. If you rotate the stage, it occurs for an instant. Now determining optic sign for uniaxial minerals. Generally it is obtained, generally we obtain the optic sign in case of optic axis figure in uniaxial minerals, and we are using accessory plates. We are using accessory plates. The accessory plates may be gypsum plate, mica plate, quartz wedge. Okay, the gypsum plate is named as half wavelength plate. Half wavelength. Why? Because it is increasing the retardation. Because the mineral is there on the stage, the mineral is there on the stage, the mineral is having respective refractive index for the two rays, ordinary and extraordinary. So there is some retardation between ordinary and extraordinary. Okay. What happens if you insert the gypsum plate? The retardation will grow by half of the wavelength. That will increase by half of the wavelength. The retardation between O and E, that is somewhat in the mineral before using the accessory. If I am using the accessory, the retardation will increase. The retardation will increase. If retardation will increase, you are going to watch higher order interference color, more intense interference color, right? So the retardation is increased by the use of accessory plate, gypsum by half wavelength. For mica, that is lambda by 4, quarter wavelength. Okay, so when there is increase of wavelength, when there is increase of retardation, what happens? There is increase of intensity of color, intensity of interference color produced. Okay, so that will show you the yellow color, or in case of gypsum plate, we are viewing yellow color and blue color. Yellow color and blue color, different colors, contrasting colors, right? Contrasting colors due to higher retardation. For mica plate, we are watching dark points, dark patches, you can say, dark patches or dark points. Okay. Then for quartz wedge, that is quartz wedge. Wedge means that is wedge shaped. That is like this. That is increasing in thickness, that is increase in thickness, right? If we are going to insert the quartz wedge here, if we are inserting the quartz wedge here, it will be like this. Okay, so at first there is lesser thickness, then gradually it grows. The thickness gradually growing, right? It is like this. Like this, right? If we are inserting that, the thickness of quartz will increase. So what happens? The bending of ray, if it is passing through greater distance, it will bend more. I have told you that if in case of a mineral, if it is like moving parallel to optic axis, it will not bend. If it increasing with distance, increase its angle, or it will pass through more distance, the ray will be bent more. So if the quartz waves is going in, entering through the stage, so what happens? The bending of the rays will be more. The bending of the rays will be more. So what happens? The isochrones, they will grow outward. The isochrones, they will grow outward in case of addition. There is two phenomena, addition and subtraction. Addition and subtraction. So what is addition? Addition means there is increase of retardation. There is increase of retardation. The phenomenon is intensified. Addition means the phenomenon is intensified. The interference pattern, that is intensified. The color is intensified, or there is intensified intensification due to which we are observing dark patches, or there is intensification due to which we are watching that the isochrones are growing outward or inward. Right? So if there is addition, there is intensification. If there is subtraction, there is opposite. That means decrease of color. There is decrease of color. There is we'll consider what happens for different plates. Talking about addition and subtraction, these are the phenomenon. It is intensified. That means the color is added. For subtraction, the color is subtracted. Right? So when there will be addition, when there is combination of same type of properties, like if let's say two bodies are working together, two of the members, they are working together. If both of them are having same mentality, then the organization will grow. Right? Like if slow plus slow is there, or fast plus fast is there, then there is addition. Okay? If there is slow plus slow or fast plus fast, they are having same mentality as I have told, they are having same properties, there is addition. For subtraction, when both of them are having mentality that differs from each other, then there is subtraction, slow plus fast or fast plus slow. Okay? Now talking about what is slow plus slow. I have given you slow plus slow. What are the two slows? One slow is for the mineral vibration direction. One slow is for the accessory plate vibration direction. The accessory plate is a mineral. Gypsum is a mineral. Mica is a mineral. Quartz is a mineral. Right? The accessory plate is also having its two vibration direction. One is slow, one is fast. Likewise, the mineral, like which section we are viewing in the microscope stage, it is having two vibration direction. One is slow, one is fast. One of them is slow, either O or E, depending upon positive and negative. Right? So one of the vibration is slow, one of the vibration is fast. Similarly, in case of accessory plate, the vibration will also be slow or fast. There is two vibration direction for accessory plate. Right? You can see here, this is the example for gypsum plate. This is the example for gypsum plate. You can see this is O ray. This is O ray. Because why I have told this is O ray? Because it is tangent to the isochrome. If I will draw a isochrome here, it is the tangent. Okay, and it is the E ray, epsilon. What happens here? I am inserting the accessory plate. There is a vibration which matches the which is parallel to the O ray. I am taking into consideration the O ray. You can take E ray also, but I am considering here the O ray. Just consider one ray, not both. Then you will be getting confused. Okay. Let's consider only O ray. So I am taking this vibration. This mineral is having, or this accessory plate is having. This one is a vibration direction. This one is a vibration direction. Right? If this will be slow, this will be fast. Okay. It is mentioned in the accessory plate itself that it is slow. That can be anything, but that is mentioned in the accessory plate, right? So here I am inserting this accessory plate which is having slow vibration direction parallel to O vibration direction in the respective quadrants where I am entering the accessory plate. Got that? There are 4 quadrants. I am inserting the accessory plate. In which quadrant I am inserting? The O ray is parallel to the slow ray of the accessory plate. Got that? These things are known. You know this is O ray, you know this is slow, and you know slow is parallel to O ray. Slow is parallel to O ray. These things you know. Now what you have to find out? You have to find out whether omega is slow or fast. Right? If you can find omega is slow or fast, then you can know whether the mineral is positive or negative. Right? Then the next thing is, you know when there is slow plus slow, there is addition of color. When there is slow plus fast, there is subtraction of color. So you know this is slow. If there is addition in this quadrant, if there is addition, then what will happen? I am inserting in this quadrant and I know this is slow, I know this is omega, this is slow, this is omega. I see that here there is addition. Addition of color means blue color. Addition of color means blue color in case of gypsum plate. In case of gypsum plate. In case of gypsum plate, that will be blue in color. Okay. So what happens if I insert the accessory plate that is having slow vibration, that is parallel with O vibration direction, and there is addition, then I have confirmed that omega is slow. Okay, because there is addition, omega should have the same mentality as I have told, that is having same properties. So omega is slow, that's why there is addition. If I have seen here subtraction, that means omega is fast, because accessory plate vibration I know that is slow, because this will be opposite, that's why there is subtraction. So if omega is fast, mineral is positive. If if O ray is slow, mineral is negative. Got that? When there is subtraction, there is production of yellow color in case of gypsum plate. When there is subtraction, there is production of dark patches in the mica plate. Okay. Talking about quartz waves, there is movement of isogears inward. Movement of isogears inward. Inward or outward? Inward is okay. Outward is subtraction. Okay. When there is subtraction, quartz wave is showing outward migration. For this is for subtraction, right? Then for inward migration, that is addition. Okay. So if you are watching, there is addition of color. If you are watching this addition of color, you will see blue color. If there is subtraction of color, you will see yellow color if you are using gypsum plate. If you are using mica plate, you can see dark patches in the place of subtraction. If you are inserting quartz waves, you can see inward migration or outward migration in addition or subtraction respectively. Okay. So if you get that there is addition or subtraction, then you can know that the ray which is parallel to slow vibration, of accessory plate, that is having same properties, that is slow, or different properties, that is fast, then you can know whether the mineral is positive or negative. Got that? The next thing is there are 4 quadrants. There are 4 quadrants in this stage. So what happens? This is subtraction. You can see if these 2 quadrants, considering for these 2 quadrants, here it is omega and here it is also omega, because the circle is like this. In both of the quadrants, this is the slow ray of accessory plate. In both of the quadrants, this O ray, for this quadrant and this quadrant, O ray is parallel to slow. For these two quadrants, you can see this is O ray, so that is perpendicular to the slope. Here which is parallel? Epsilon is parallel. Here epsilon is parallel. Most of us get confused why here it is subtraction and here it is addition, or here it is addition, here it is subtraction.